Hello everyone, welcome back. This is Engineer Hussein Mwasabi. Alright, so in this video we'll be covering what is known as position vectors. So before we begin, don't forget to like, subscribe, as well as hit the notification bell. Alright, let's get to it. Now when it comes to position vectors, you need to understand that we're looking at vectors that are able to symbolize either the position or you could say the location of any given point that you are interested in with respect to another arbitrary reference point. In a nutshell, we're talking about vectors that are able to locate one point in space relative to another point. So let's say vectors that are able to locate one point in space relative to another point. Just like that. Now, under position vectors, the first agenda I want us to look at is learning how to find or to determine the length and its direction angles from one point towards the other, which is literally as one saying from one point relative to the other point. Okay, so we'll best understand this with an example. So let's dive to the example. So the example says an elastic rubber band is attached to points A and B, as shown in the figure. All right, let me change my pen to red. So this is the figure that we're having here. We're being asked to determine its length. So we want to know the length of the rubber band, this rubber band there. And its direction measured from A, so this is A, towards B. Wonderful. All right, let's get to it. Let us determine the length and its direction. So these are the steps we're going to follow. Let's start with the first agenda. Let's determine the length. So these are the steps we have to follow. Step 1. Let's locate the positions. Now when I say locate the position, what I mean is that we have to locate the location of each point in space. We have A and point B. So let us locate point A. Now if you look at point A, we need to know the position of point A in space, in a sense that we need to know its position in the I-axis, J, as well as the Z, which is the K. So we need to know the position in the X-axis, this axis. We also need to know the position in space of point A in the Y-axis, as well as the Z-axis. So be mindful of this. When it comes to the axis, please make sure you pick the points correctly. Know the position of that particular point if it's either in the negative zone of the axis or the positive zone of the axis. Now if you look at point A, we've been given these distances. We have the 3 and the 1 meter there. Now let's start with locating the position in the X, which is the I-axis. So now what length have we been given that will help us to know the position of A in the X-axis? So we know that X is in that direction, isn't it? So moving on to position A, we have this location given there for the X-axis. So this will tell us that we have 1 in the I. So this is 1 in the I. Then we need to look for the position in the Y. So this is the Y-axis that we have. Now, in this case, we don't have the position of A in the Y. A doesn't sit anywhere in the Y-axis. Therefore, it is 0 in the j-axis. Then we have to move on and look for the position of A in the z-axis. In the z-axis, as you can see, we have the distance from this point taking you all the way to A, which is what? 3 meters downwards from the position of what? Z. So, as you can see, we're having 3 meters here. That shows you the position of A in the z-axis. So, now be mindful, as you move, this is the origin of the axis that you have. So, as you move downwards in the z-axis, you are going in negative zone. So, this is going to be basically -3 in the k-axis, like that. And this will give you the position of A in space. Once we do that, we also have to determine the position of B in space. We need to look for the position of B in space. So for the position of B, we'll start with the position of X, the X position. Let us look for the X position for B. So for the X position, we're going to look for where B sits in the X-axis. As you can see, we have to follow the X-axis like that and check exactly where it is. So in our case, in the X-axis, we're having this line here that has been shown. So it's easy for us to understand that from this point here where these are intersecting, we're having the length that we will know for what? X. So here we're having X to be what? 2. Now we know that in this zone we have the positive, while in this zone we have the negative. So it's clear for us to understand that this 2 here is going to be negative. So this is going to be -2 in the I. Then we're also going to look for the position of B in the j-axis. So in the j-axis, you will see that we're interested in the y-axis. The y-axis. So in the y-axis, what position do we have? So in the y-axis, from the point where they meet, this length will show us the y-axis that we're interested in. So the y-axis, as you can see, has been given that value to be 2. So in the y-axis, it is in the positive y, because this is the positive and that's the negative. So it's in the positive y, so it's going to be +2 in the j. Then we have to look for the position in the z-axis. So we know that they're meeting at that point. So in the j-axis, it's either you go up or down. So at that point, you can go upwards to know the position of what? B. So that would be what? 3. Because we know that as you go upwards in the z, you go in the positive. As you go downwards, you go in the negative. So it's going to be +3k. So these are the located positions of A and B. Always look for the point of reference that you are interested in. For instance, you look for the point of interest. Let me just give you a recap. At A, this is where the lines are meeting. To know the position in the X, you know in the X, you either have to go left or right. So in the position of X, I have to go to my right hand side, which is the origin, which is the 0 point, to know exactly what X position I have. And in this case, I am having 1. Then to know my Z position, Z goes up and down. I'll go upwards like that to know where I'll have my value line. Same thing that I did for what? The Z. Position B, as I was collecting the values. So to find Y, you go to the same position and look for where Y sits. But in our case at A, we didn't have anything. So please make sure when collecting these points, you collect them with accuracy, because mostly this is where the mistakes are created. So remember, look for the intersecting point, look for the positions in the X. You know in the X, you go either downwards or away like that. So you know that you'll be having that point there in the X, which is there. So please be mindful about it. All right, so I guess that's that, which we need to know about collecting the positions of our particular points. So the next thing we're supposed to do is simply just to find the position vector from one point to the other. So Step 2, we need to find the position vector. So find the position vector. Now this position vector has to be from one point to the other. Now what I mean from one point to the other, I mean that it should be from one point relative to the other. In our case, as you can see, it is A towards what? B. So what I mean when they say A to B, it simply just means as one saying, okay, I will move, or let's just say it means that I'll be at B from what? A. That's what it means. So to find the position vector, which is denoted with R, be mindful when they say A to B, this means it's B minus A. A to B, that is B minus A. But if they said B to A, that would have been A minus B. Let's get that right. So A to B simply means we're saying B minus what? A. So it means that the positions in B minus the positions in what? A. So I'm going to write my I, J, and K. Then I'll write the positions in B first. The positions in B first that I have are the positions that I have as follow, which is minus 2, positive 2, and 3. Then I'll write the positions that I have in A, which is 1, 0, and minus what? 3. And the sign of action is the subtraction sign. Then I'll do my computation. I'll say minus 2 minus 1. So this will give us negative 3. Then negative 2 minus 0. This will give us negative what? Sorry, it's 2 minus 0, not negative 2 minus 0. That was a mistake, sorry. So it's 2 minus 0 because we have to follow top and bottom. Like we said, minus 1 minus 2 minus 1, which gave us minus 3. So 2 minus 0 will have to give us what? 2. Then again, we'll do the same thing here, in this portion here. We'll say 3 minus 3. So 3 minus 3, in this case, because you're having 3, then minus, again, the minus 3 there, it means you end up having 3 plus 3, which will give you what? 6. So I guess at this competitive part, we all agree that we can understand how to go about this. Just say minus 2 minus 1, that will give you minus 3. 2 minus 0, that is a 2. 3 minus minus 3, that is a plus 6. So which means that R has the positions which are minus 3 in the I, plus 2 in the J, and plus 6 in the K. So these are simply the positions that shows you how you're going to move or travel from A to B. These are the positions. So in a case where they just said find the positions of the length, okay, measured from A towards B, you would have just ended here. But in our case, they want us to find the length. Now, one thing you should know is this, that the length is equal to the absolute form of what? R, which means that the length is equal to I squared plus the root of I squared plus J squared plus K squared, which means that the length which we're interested in, which is the absolute form of R, which is the position vector, is equal to, if I square all these values, I say minus 3 squared plus 2 squared plus 6 squared, we'll get the absolute form, which is the length, to be equal to 49. If you root 49, you will get 7. So 7 is simply the length of this rubber band in question. But now we also have to put out the units of measure for our particular length. Now, as you can see, the positions are given in meters. So we're also going to write this as what? Meters, as you can see. So this is simply the length of the rubber band that you have, which is attached to point A and B, as shown in the figure. So be mindful. how you go about finding the length is first that you have to locate the positions, and make sure you're very careful when you're locating the positions so that you don't make mistakes. Other than that, also find the position vector from one point to the other. And remember, when they say, for in our case, when they said A to B, it simply just means that B minus what? A. And after you do that, you can always do this so that you are accurate in order to get the precise positions of your position what? Vector. After that, you end up having the positions that will show you how you should travel from one point to the other. And if you take the absolute form or the magnitude of those positions, you end up getting the length which you're interested in. Now, this only just answers the first portion of our question. Now, we also have to find the direction measured from A towards what? B. So let's do that. Now, we know that the positions of the vector we have is minus 3 in the I, plus 2 in the J, then plus 6 in the what? In the K. And we know that the length is found to be 7 meters, isn't it? So let's do that as our data. Now, for us to find or determine the direction from one point relative to the other, there are also some steps we have to remember. So if we had to follow the steps, be mindful that step 1, all you have to do is to find the unit vector. So find the unit vector. Now, this term unit vector just talks about a vector whose magnitude is equal to 1. That's a unit vector. A vector whose magnitude is equal to 1. Now, unit vectors in some books is referred to as the direction vector. Okay? The direction vector. So, in case you find someone writing direction vector, just be mindful that they're just talking about this guy called the unit vector. And always remember that its magnitude is equivalent to 1. So, what we'll do is that we'll have to follow the formula for the unit vector. So, we say unit vector is equal to U, then the position in I over the absolute form of R, then the position of R in the J over the absolute form of R, plus the position of R in K over the absolute form of what? R. This is the formula that we use. Now, be mindful that U just simply denotes the normalized vector or the unit vector in the question or in question here, and R is the position. R in the I, J, and K shows you the position. So be mindful that R should never be 0, because if you get 0, obviously you know that's going to be undefined. 0 at the bottom, it won't make sense. So remember that. So all we have to do is to say our unit vector is equal to R in the I is minus 3 over the length, which is 7, plus R in the J is 2 over the magnitude, which is 7, which is the length, and R in the K is 6 over the length 7. And this is simply our unit what? Vector. So be mindful of that. Now the unit vector obviously have to have the what? The position. So this is in the I, this is in the J, and this is basically in the what? In the K. So be mindful that this is how you get your what? The unit vector. Be mindful that this is just simply the length, which is the absolute form of the position vector that you found. So be mindful that that's how you get your unit vector. Now, there's a way you can actually prove this. If you find if you find the absolute form of the unit vector, if you say, okay, let me root this, say the root of 3 over 7 squared plus 2 over 7, you can prove this is just a proof over 6 over 7 squared. This should give you what? 1. If you get 1, then your unit vector is accurate. So, as having a 1 brings in the whole entire naming of the unit vector. So, that's literally how you go about finding the unit vector. Now, once you have the unit vector, we can now find the direction angles that we want. So, the direction angles, remember the direction angles, we say cos alpha is equal to R in the I over the absolute form of R, which means that alpha is equal to cos inverse of R in the I over absolute form of what? r. So alpha is equal to cos inverse of the position of r in the I. We know this is going to be minus 3 over 7. So we can say that alpha is equal to 115 degrees. Then we'll do the same thing for beta. I'll say cos beta is equal to r in the j over the absolute form of what? R. So this means that beta is equal to cos inverse of, this would be 2 over 7. So beta is equal to, this will give us 73.3984504. Okay, so I prefer rounding these things off. Okay, let's just round off to, let's say, 1 decimal place in this case. So this will be 73.440, let me just say 4. 73.4 degrees in our case. If we want to go to say 40, yeah, that's rounding off to 2 decimal places. Then we also have to find the directional angle for gamma. So you know cos gamma is equal to the position of r in the k over the absolute form of r. So gamma is equal to cos inverse of k over the length, which is 6 over 7. And gamma will be equal to, this will be 31.002719113. For round off, gamma is equal to 31.0 degrees. So these are the positions of the unit vector that we found, and these are the directional angles that were asked to find in question. So this is how you determine the length and its direction measured from one point to the other. So be mindful, it's very important to know how to find the unit vector, because the unit vector will actually help you to find a lot of things when it comes to force vectors. Then also always put in mind how we find the directional angles. The procedure is the same like we were doing in our previous subtopics. So we'll be doing the same thing over and over again. All right. Thanks for watching. Don't forget to like and subscribe. And remember, slow progress is better than no progress. If you have any queries, you can always reach me on WhatsApp on the number 077-149-5252. Remember, strategize before you become a statistic, and let's try and push for that A+.